As the whole world knows now, OceanGate's business was taking adventure seekers on these Titanic dives for $250,000 a ticket on a one-of-a-kind carbon fiber submersible called the Titan.
Carbon fiber is a great material. It's better than titanium. It's better than a lot of other materials.
This is Stockton Rush, the CEO of OceanGate and the designer of the sub. Last Sunday, as he was piloting the sub to the Titanic, it imploded, killing him and his 4 passengers. The Titan wasn't like any previous deep-sea submersible. There was no dashboard, just a touchscreen computer and a single power button.
We only have one button, that's it.
But many of its components seemed surprisingly cheap. For views outside the sub, he had installed store-bought security cameras. And then there was the steering unit.
We run the whole thing with this game controller.
Come on! So it seems like a lot of the way you made this is by taking off-the-shelf parts and sort of MacGyvering them together.
Yeah, pretty much.
Does that not raise anybody's eyebrows in the industry?
Oh yeah. Oh yeah. Yeah, no, I'm definitely an outlier. There were a lot of rules out there that didn't make engineering sense to me.
Why would you get on that dangerous sub?
Well, first of all, Stockton Rush had the credentials. He majored in aerospace engineering at Princeton. He designed and flew his own airplanes. He'd designed previous submersibles. Second, he was emphatic that the important parts of the Titan were rock solid, like the carbon fiber body for which NASA served as a consultant.
There's certain things that you want to be buttoned down, and that's the pressure vessel. Once the pressure vessel is, you're certain it's not going to collapse on everybody, everything else can fail. Your thrusters can go, your lights can go, you're still going to be safe.
I was also impressed by the sub's 7 redundant systems for returning to the surface.
These are roll weights. We can actually roll this up and those come off. That gains us some buoyancy to come back to the surface.
Okay.
These triple weights, we call them, are hydraulically driven.
Expedition manager Kyle Bingham.
Underneath this tray hang these bags. We're around 35 pounds. And those hang down there. Typical dive will have 8 of them. We can also use our thrusters. We have enough power to thrust back up. And then under this last fairing here, we have our variable ballast tank or soft ballast. It's an air bladder that we use a big 10,000 PSI air tank that's under the tail to fill that up, fill it with air, and then it helps bring us to the surface.
There were even sandbags that detach automatically after about 16 hours, even if everyone inside had passed out. Their connectors would dissolve in seawater.
So you have a backup of a backup of a backup of a backup of a backup.
Correct.
Finally, the crew seemed to foster a culture of safety. There were checklists, inspections before and after every dive, and a 3 strikes rule. If 3 things seemed out of the ordinary, no matter how minor, they'd cancel the dive.
In OceanGate's first 2 summers of Titanic operations, it spent a total of 50 days floating above the shipwreck site. But because of waves, bad weather, and malfunctions, the Titan actually made it to the Titanic only 12 times.
But as early as 2018, there was concern about the Titan's design. A former employee says that when he raised safety concerns, Rush fired him. That same year, a group of submersible engineers urged Rush to seek certification of the Titan by a safety agency. Rush declined, saying that regulation would stifle innovation.
At some point, safety just is pure waste. I mean, if you just want to be safe, don't get out of bed, don't get in your car, don't do anything.
Yeah.
At some point, you're going to take some risk, and it really is a risk-reward question. I said, I think I can do this just as safely by breaking the rules.
Retired U.S. Navy submarine captain Alfred McLaren is not impressed by OceanGate's innovations. He theorizes that the Titan failed not because it was made of carbon fiber, but because it was made of 3 dissimilar materials: carbon fiber, titanium, and plexiglass for the porthole.
When you have different materials, different molecular structure, they have different coefficients of expansion and compression, and then you make repeated cycles in depth, of course you're going to work that seal loose. And that's why submarines don't run around with any portholes at all, come to think of it. it's a weak point.
I couldn't think of any other scenario in which a sub would be lost where it lost comms and navigation at the same time and stayed out of touch and did not surface. The only scenario that I could come up with in my mind that could account for that was an implosion. Carbon fiber composites are used very, very successfully for internal pressure vessels, like let's say a scuba tank. And you can get 2 or 3 times multiple of what you could get out of steel or aluminum for that type of pressure bottle. But for something that's seeing external pressure, all of the advantages of composite materials go away and all the disadvantages come into play. So if you're using a uniform material like steel or titanium or ceramic or acrylic, you can do computer modeling with a high degree of accuracy and confidence. The second you start doing carbon composite or any kind of composite materials, you're introducing 2 materials that are in contact with each other. The filament itself and then the epoxy matrix that it sits within. And at that point you have degradation failure. So we always understood that this was the wrong material for submersible hulls because with each pressure cycle you can have progressive damage. So it's quite insidious because you may have a number of successful dives, which is what happened here, and then have it fail later. They call it delamination when water ingress starts to force the layers of the fibers apart, and theoretically you can hear it. I actually believe they heard it with their ears, not through the sensor system in the last moments of their lives, and that's quite a horrifying prospect. But even in my own sub, which had a steel hull, I knew that if I dove several 2 or 3 times, it was probably good to go because you could cycle steel hundreds of times, if not thousands of times. But that's not the case with composites. So it's quite insidious, and that I think lulled them into a sense of confidence and led to this tragedy. But these are known things. They're known within the engineering community.
Every year, people do die skydiving and scuba diving and climbing Mount Everest. Tragic every time, and yet people still keep coming. Some people just have that itch. For them, danger is the point. The risk of dying gives meaning to living. I think Stockton Rush was among them.
The world mourns the loss of Stockton Rush, P.H. Nargeolet, and their 3 passengers, British billionaire Hamish Harding, Pakistani businessman Shahzada Dawood, and his son Suleiman.
Thank you for watching. If you haven't already, please consider subscribing and ring the bell to be notified when we upload new videos. Thanks for your support.